Hello. Okay. Oh, hi guys. I hope you can understand and you can just give your hint. Okay. Um, you can subscribe to the channel anytime you feel like. Just click the bell. Invite other guys. You can just share this the video also. You can share your comment and just say whatever you feel like. Okay. If there is any exercise you would like to you're not understanding well, you can just come up and just send this exercise. Whenever we see this and whenever we have a time or the answer for this, we will just post it right away. The main intention here is just to make you feel easy by solving this higher degree and first order differential equation. So this will be our last class, if I can say like this, our last section of solving this degree differential equation, because the next video that will be uploaded, it will be about higher order differential equation. Okay, so be ready for the differential equation. Now the question is, why is Veloso only posting videos on differential equation? Because it is like it is something that people say that is very difficult to understand. So according to people saying and according to what people are like according to the people needs, I'm posting these videos. Okay, because I know many people cannot understand that much well what is um, differential equation. But see, the keys word to understand differential equation is like studying systematically and also knowing factorization and integration. Basics formula of integration are the base. Okay, also knowing trigonometry is very important to you to solve these problems, and the rest is only basic concept of math. Okay, now suppose we have this equation upon here. So we have p squared plus px and y minus y. Okay, see, I will solve this equation as I always said you guys. Okay, in this expression, as you can see like this. Okay, you can solve in terms of x or in terms of y. Okay, because y here is linear, x is linear, so I can solve either by one or other method. And so yeah, and I'm going to solve by x. Okay, because I have solved many exercise by y. Now I will solve by x so that you can have a glimpse or a like a hint on how to solve when you want to solve by x. Okay, p squared plus px minus y. That's the equation. Now see, it is p squared and this and this. So to solve by x, okay, I'm solving by x. Okay, so to solve by x, I have to make x as a subject. Okay, then everyone will be a function of x. Okay, sorry, then p and y will be variable and f, that is x, will be the function. So pick this up and go out there. So you get something like this. So x will be equal to y minus p squared all upon p, right? So the next step here, after making x as a subject, the next step here is applying derivative dx dy. Okay, then solve for this one, dy of y upon p minus, do this dividing by this will be p. Okay, now just solve this equation, this derivative. So y and p are both function of y. Okay, so p is a function of y. Why? Very simple, because p is dy by dx. Okay, so p has a bridge. Okay, coming from p. From p we go to y, and from y we go to x. You see, so p is also a function of x. Okay, now that we understand this, let us just apply differentiation of this one. This one will be applying this quotient derivative. Okay, we know what happened in there. U derived v naught minus u do not v there with v derived, then v squared. Go for this one. So it will be y deriving, it will be 1 time p do not derive minus y do not derive time p which derive. This will be d dp upon dy. Okay? We cannot say that this is 1, okay? We just know that this p is function of y. So it is at some point derivative of y. But the point is, it is differentiated by y also. But the point is that we do not know what is dp by dy, okay? That's the point. So we have just to grab it like this, then divide it by p squared. Okay, this is for the first case. Now the second, minus dp of dy. This is dp, dy the same. Okay, so here it is dx, dy. Now the next step is just to make this dx by dy as a p, or function of p. Now see, we know that dy dx is equal to p. So what is dx dy? It is the opposite of dy dx, right? So if it is the opposite, if I do this one, minus 1, this is dx upon dy, that is 1 upon p. Okay, then substitute this 1 upon p here. Then here, just solve. This divided by this, it will be 1 upon p. Then this guy dividing this will be minus y upon p squared dp dy. Okay, minus dp dy. Then what you have to do this. So see these two expressions, they are equal. They are in different members or in different sides. So it will be 0. This guy and this guy, you can just take common dp dy. Okay, dp dy. Then here you are going to have minus. Oh, sorry, it's all minus. You can take minus also. It will be y upon p squared, right? Minus 1. So now see, here you got two values. We know that when we have a times b equal to 0, okay, the condition necessary to this to be true is that a must be 0 or b also have to be 0, just like this. One of them must be 0, so that this expression will be 0, okay? And two of them can be also 0, so that this two will be 0, okay? Nice. See, this is what you're going to apply this one. dp dy must be equal to 0. Do please remember that whenever we are solving for x and y, we have to find only what is the value of p. And after finding this value of p, we will go just for the substitution, the main substitution that we did, that is p is equal to dy dx. Okay? Just like this. And we have also here y upon p square minus 1 equal to 0. Okay, what's the next step here? Just to find what is the value of p. Okay, to find p, this is very easy. Multiply by p square. Okay, what will you get here? You get something like this. This and this will be y minus p square equal to 0. Okay, just multiplying this one, 0. So it means that p square will be equal to y. So what does it mean? It means that p is equal, here it is plus, okay? Yeah, then it will be plus. This is negative. Here it means that p square is equal to minus y. So, okay, p square is equal to minus y. It means that p square is equal to minus 1, but it is p square. Okay, I want the value of p. So I have to, this one, to to rest 1 by 2, to take this 2 here. I just want p. Okay, the value of p, minus y, and here 1 by 2. Here there are some conditions that you have to satisfy, that if you have this one, this is root square. So minus y must be greater or equal to 0. Okay, just like this. For minus y greater or equal to 0, then you can say that this is true. Okay, and but it is in real number. Okay, but I don't know. Okay, it is in real number. Okay, in real number. You can do this one, but if it is in like range of complex number, so it can be like that. So this minus 1 will be I square, and you can solve by this one. Okay. Now, so this and this, p will be equal to minus y raised to 1 by 2. Okay, this is your second p. Now our first p will be there. So here, what you have to do, this y go there, so I'll get dp equal to 0 dy. Now I can integrate this two. It will be p equal to c. Okay, I have these two p's. These are my two values. What do I have to do? See, after finding this, okay, before we learned that from here, we can solve this equation, okay? dy by dx is equal to c. Can you see? So p is equal to a c. So dy by dx is equal to c. We had to, okay, we have to go back in here, and also dy by dx will be equal to minus y 1 by 2. And here we can solve this equation and also go on and on. Nice? But the question is, the point here is, the point that I wanted to just to clarify here is that once you found your value of p, you are solving for x or you are solving for y, and once you found the value of p over there, once you find the value of p, if you are solving for x and y, so if you found the value of p, just grab these two values and you will substitute in here, okay? So, okay, instead of going this way and apply integration again and again, you can just directly, okay, you can just directly come and minimize your effort, okay, minimize your effort, okay, you can just directly come and solve and write this one in this way, okay. As you have two p's, two value of p, so we will write, so for p equal to c, okay, and I will just put this value of p in the main equation. This will be, what is c? P is equal to c, so it will be c squared plus c times x minus y equal to 0. So this will be our solution, the solution for the first p, okay? So it means that I will get this expression over here. So c squared plus cx minus y is equal to 0. Okay? Now, for p equal to minus y, okay, 1 by 2, and p squared, we know will be minus y. Okay? So differential equation, it is, how can I say, it is taking the range on all domain, like not only real numbers, okay? It is for imaginary numbers also. So complex number also part of solution of this differential equation. So this one, as we can see, okay, this one as you can see, you can just, instead of writing like this, you can also write in this way. P is equal to E, like, sorry, like this is minus 1. So we know that in complex, I square is equal to minus 1. So here I can put I square, okay, time y, okay, raised to 1 by 2. What will it be? It will be something like this, okay, something like this. This I will go there, so you will end only, okay, in an expression like this. This I can go out, okay, here. Let me write down here. So P will be equal to, okay, root I, this one, time I, okay. This will be the way to be write this, this solution. And the same here, okay, you have minus y, so put here I only, like I square, okay, you can put just y I square will be this value, okay. So here we have y 1 by 2 times I. Okay, what is I? Again, I is minus 1. I square is minus 1. So here, then what I will do, I will just substitute. Where I find P, I will put this expression. Where I find P square, I will put this expression over here. Nice? Put this then, okay? So P square will be y I square. Okay, then plus, okay, this expression, this is like p, only p. This will be y 1 by 2 time I, okay, then time x, okay, minus y. It is equal to to 0. Okay, I can write in this way. So this I square, we know this is minus, okay, minus y plus, okay, plus, and this expression will be the same. We can't change. X root of y, okay, time I minus y equal to 0. See, minus y, you can write minus 2y. Okay, so these are the solution. Okay, sometimes we don't have to go through this integration again and again. Okay, so we can just put these two as a solution. So it means that here the solution, the general solution, will be directly what? C squared plus cx minus y time minus 2y plus x, okay, root y I equal to 0. Okay? Yeah. This will be your general solution, and this is okay. Now let's go for the next exercise. Okay? Let's pick up this next exercise, and we are going to apply the same. Like, suppose we have y minus sinus dy dx equal to x plus 1, then dy dx. So what should we do to solve this exercise? That's the point. So I can solve for y. This can go there. Okay? What will I get? I get just like, we know if we are solving, okay, let me see, just solving for y. Okay? We are solving for y. Solving for y. If we are solving for y, the first step, it may be for y or for x or for p. The first step is always making, okay, let p be equal to dy by dx. Always the first step. Then y minus sinus of p equal to x plus 1, then p. Okay? Then make your y as a subject. Y is equal to sine of p plus x plus 1 p. Then derive dy dx. Okay? And this guy also dx, it will be sine of p plus x plus 1 time p. Okay? When you derive, you get this one, this expression. This will be cos p dp dx plus this again. I will derive this, then derive this. So it will be p, when I derive this one with respect to x, then plus this one will be x plus 1 dp and dx. So how about here, dy dx? Dy dx, we know that is p. Okay, so now let us solve this equation. This one and this one will be cancelled out, will be 0. So 0 is equal to cos p. Okay, if you take this common, these two common, you get cos p, then plus 1, okay, and here dp dx. It's okay. From here it's nice. Sorry, it is x plus 1. X plus 1. Okay, dp dx. Now what's the next step? The next step here is just to make it equal to 0. dp by dx is 0. Okay, and cos p plus x plus 1 is 0. Now how to solve this one? We know here p will be equal to c, okay, p will be constant, and At this point, cos p will be equal to minus x minus 1. Then c, cos p is equal to minus x minus 1. We want p. If we want p, what do we have to do? We have to apply the inverse cos, okay? Cos inverse of p and cos inverse of p, both sides. We are going to have cos inverse of cos p and cos inverse of minus x minus 1. Okay, so what we are going to have? Cos inverse of cos p, it's equal only to p. And here it's cos inverse of minus x minus 1. This is your p. As well as p here is equal to c. These two p are the values that you are going to substitute on the main equation. Okay? So go there, and where you find p, substitute it there. Okay? Yeah. Let us solve it here. No, it's better do not eliminate. Now see, for p equal to c, then substitute. It will be y minus sinus c equal to x plus 1, then time c. This will be your first value. Okay? So y minus sinus c, then minus x plus 1 c equal to 0. This is the solution of this for our first expression. Okay? For our first p, we know this one. Now, for the second p, for p equal to cos inverse of minus x minus 1. We know that the cos inverse, okay, cos inverse function, it's neither even or odd. So we cannot just go and take this minus outside and things like that, okay? It's not like that. So we have just to keep it like this, okay? Then I will get something like y minus sinus. What is p? P is cos inverse of minus x minus 1, okay? It's equal to x plus 1. Sorry, the space is not enough, so I will just have to enlarge a bit here. I will write here down. So it will be y minus sinus of cos inverse of minus x minus 1. Okay. Then, see, here I will call just this expression up here. So it will be minus x plus 1. Okay. Then, what is p? P is again cos inverse of minus x minus 1, okay, equal to 0. So this is the second solution of this equation. Okay, we can do some changes here? Yes, we can do. We can do some changes, some simplification here. Like, see here, you have cos, okay, cos sinus of cos inverse of this guy. Okay, so there is a very good way. So we know that whenever we have sinus of cos inverse of minus x minus 1, okay, how much will it be, or what will it be? So we know that when we have sinus inverse of sin x, this is equal to x. The same, cos inverse of cos x, it's equal to x. So if I have sinus of cos inverse, what should I have to do? What would I do to find this? So very easy. See, you have to express this sinus as a function of x, as a function of cosinus, so that you can get this one, and this will be expressed in terms of this argument over there. Okay? So we know that sinus square of x plus cos square of x is equal to 1. Then sinus, okay, sinus square of x is 1 minus cos square of x. So if I put here, okay, 1 by 2, and here 1 by 2, we will end in an expression like that. Sin of x is equal to root square of 1 minus cos x square. Okay? This is the expression that relate, okay, make a a relation between sine x and cos x. Then I will put just right there. Okay, let me right here. I will put just right here. So this will be root of 1 minus cos inverse, okay, cos inverse of minus x minus 1. Okay, sorry, not cos inverse, cos square. Okay, it will be cos square of cos inverse of minus x minus 1. Minus x minus 1. Okay, now you see, this is cos and cos. What will it be? It will be root of 1 minus x and minus 1 all square. Okay, yeah, this will be the solution for this expression right there. So I can write this solution also in this way. Okay, it will be y minus, okay, root of 1 minus x minus 1. Okay, all square. We know this negative, this is square, this will be positive at all, plus 1. Okay, then minus x plus 1 times cos inverse of minus x minus 1 equal to 0. Okay, yeah, that is the nice thing about this. So how to write the general solution then? So the general solution, I will write here down. Okay, this is the general solution. General solution will be equal to y minus sinus c, okay, minus x plus 1 times c multiplied by y minus root 1 minus x plus 1 square, okay, minus x plus 1 and time cos inverse of minus x minus 1, okay, minus x minus 1. It must be equal to 0. Okay, this will be the general solution of this equation. Okay, yes. Now, just a bit of pause, look at this, what we did, and then and so on. Okay, so fine. Okay, yeah, what's the next step? Let me see if I didn't skip anything. Okay, no, it's fine, it's okay. Now let us solve for the other exercise. Okay, yeah, let's go for another exercise like, okay, the more we practice, the more we solve exercise, the more you will get like enlightened, and things will be easy to you to solve. Okay, the next exercise is this. Okay, x raised to 4 plus 2x squared plus 1 minus 4x dy dx. It's all squared equal to 0. Nice. How to solve this equation? That's the point. See, can I solve for x? Surely not, because it will be difficult to you to solve for x here. Yeah, very complicated. Okay, because if you solve for x, remember, here you do not have linear x, so forget about it. Just go for p. It will be easier for you. So then, what should I do with this? This expression, if you look at deeply, you will understand that this expression is nothing more than a perfect square, this one. This is a perfect square where you have x square plus 2 times x square times 1 and plus 1 square. Okay, this is a perfect square. So x square, okay, if it is a perfect square, so I can write in this way, x squared plus 1 root square, plus 1 squared minus 4x. This one I can also make as a square, okay, so that I can have difference of squares, and it will be easy to me to simplify or to, how can I say, to factorize and find p as a subject. We know that here it is p, okay, this one will be p. So what I have to do, 4x p squared equal to 0. Now, x squared plus 1 this is square, minus. I have to make this one, to convert this one in a square also, so that this guy, this whole can be square. So 2x or root x p, okay, square. It is equal to 0. So in this way, it will be easier to me to find what is p, okay, to find my p. So this guy will be x square plus 1, okay, minus 2 root x p time x square plus 1 plus 2 root x p equal to 0. So it will be the same. What will be x here, or p here? P will be equal to minus x square minus 1, okay? Sorry, minus x square minus 1 all upon minus 2 root x minus 2 root x. This is the same as x square plus 1 all upon 2 root x, okay? And another solution will be p equal to minus x square minus 1 upon 2 root x, okay? So in this way, then you can solve this one. So these are the values of p. P is equal to this and this. You can also find it will be 1 by 2 x 3 by 2, okay, plus, okay, plus 1 by 2 x minus 1 by 2. Okay, if you feel like you can do like this one, okay? After finding what is your p, then go straight to your function or to your differential equation and substitute. Just substitute your p and you will get the solution of this equation. Just like this, easy, okay? No need to go in this way anymore. Just come here and put it there, okay? 4p equal to x squared plus 1 upon 2 root x, okay? I will write here. And here, it is 4p equal to minus x squared plus plus 1 upon 2 root x. Here, what I will get, okay, what will I get? X raised to 4 plus 2x squared plus 1 minus 4x times x squared plus 1 upon 2 root x equal to 0. Okay, I got only an expression of x. And here also, x raised to 4 plus 2x squared plus 1 minus 4x times minus x squared plus 1 to root of x. It's equal to 0. Now there, okay, from there you can solve, you can find, you can simplify, apply some simplification like this. Here it is x squared plus 1 square, and here minus 4x. Okay, here it is x squared plus 1, and here it is root x 2 equal to 0. So x squared plus 1, x squared plus 1. You can take common x squared plus 1, okay, and it will be x squared plus 1 minus 4. 4 and 2, it will be 2. 2, okay, and x with here, it will be 2 root x. 2 root x equal to 0. Okay, the same will happen here, so you will get the same. Okay, x, sorry, here it is x squared plus 1 squared. Okay, then minus 4x. Okay, these 2 and these 2 will be cancelled out, and these 2 also. So it will be only like 2. Okay, this and this, 2 root x times x squared plus 1 equal to 0. Take x squared plus 1 common, so you get x squared plus 1 minus 2 root x, okay, equal to 0. And let me see. Yeah, they can't be equal. Okay, minus will be positive. Okay, so this is minus, so this here it is positive, here it is positive. Nice. These are my solution. So what can I say about general solution? My general solution will be x squared plus 1 time x squared plus, okay, x squared plus, minus 2 root x plus 1. Okay, this is my general solution at all. Yeah, I can just do this, and this also x squared plus 1, and here x squared plus 2 root x plus 1 equal to 0. Okay, so yeah, this is my general solution. As you can see, that's okay. Nice. Now let us go for the last exercise. This is this one, okay? How to solve, okay? How to solve this equation. Let us see. Okay. So see, for this last exercise, like this is dy dx equals to 3 minus x equal to 0. Right? So what should we do for this exercise? See, just first substitute here is p cubed minus a equal to 0. So it's p cubed minus a equal to 0. What does it mean? Solve for p. P cubed minus 2 cubed equal to 0. Then I will let me just tell you something. Because whenever we are solving differential equation, like higher degree differential equation or higher order differential equation, we are solving this differential equation in a complex domain. Okay, it means we are solving whether for real, non-real, that are imaginary numbers. Okay, so we are solving for in complex. How can I say, in complex domain, okay? Yeah, so that's why here you will see me sometimes using imaginary roots and things like that, just like that. So here I have this one. So what will it be? When I have a cubed minus b cubed, it's equal to a squared, okay, plus ab plus b squared times a minus b. So this is the same that we have here. So you get p minus 2, then p squared plus 2p plus 4 equal to 0. Then how to find this? So I know that here p will be equal to 2, okay? Then what will be the second p? Here I got p squared plus 2p plus 4 equal to 0. We know that this is how can I say, second degree. This is a second degree like algebraic equation. So this one in real has no solution, okay? But here, as we said, whenever we are solving differential equation, okay? Sorry. Okay, whenever we are solving differential equation, I don't know if you got this one because I forgot to use this microphone. But anyway, it's fine. Okay. Anyway, it's fine. It's okay. I will just do the explanation again, okay? So we have here this expression. This is dy by dx cubed minus 8 equal to 0. So we substitute this one. This is p cubed minus 8. What is 8? 8 is 2 raised to 3, okay? Even if this one here, we didn't have 3, okay? We should just make a way to this to become 3, okay? We should just make some artificial calculus to make it like a power of 3, okay? Just like this. In this way, p cubed minus 2 raised to 3 will be equal to what? As we can see here, a cubed minus b cubed is equal to a squared plus ab plus b squared times a minus b. So, yeah, this is true. Then this will be true, okay? Just following this formula. Then here I'll get two solution, p equal to 2, and the second one is this one, okay? But see, this second exercise we cannot solve in, how can I say, in real domain. So we only have solution for complex domain, in complex domain, like using imaginary numbers. So using imaginary numbers, so because differential equation is an equation that is applicable for all domains, like for complex domains, okay? And complex domain has as a subconjunct, like this real number are inside the complex domain analysis. So this is okay. Let me solve. So here you got delta is equal to b squared. Okay, what is b squared? This expression that is in p, term in p. So this will be 2 squared minus 4 ac. A here is 1, c is 4. Time 1 time 4. How much will it be? It will be 4 minus 16. And this will be minus 12. Okay? We know that minus 1 here, this minus, will be made as 12i squared. Okay? This is what we mean by imaginary number. In imaginary number, minus 1 is equal to I squared. So now P will be equal to minus B plus or minus root delta 2A. So here we know that P is equal to minus B. What is minus B? This will be minus 2 plus or minus root of 12i squared. Okay? All by 2 times 1. Now C. Here you get 2, 3, okay? This I will call P1. This here is P2 and 3. Okay? P2 and 3. Here it is P2, here it is P3. Now see, 12. What is root of 12i squared? Then, I know that 12 has not exact root, but I can just simplify this one. I can simplify and make this one. It is root of 2i squared times 3. So, it will be 2i out and 3. Okay? Yeah. In this way, you are going to have this one. This will be minus 2, okay, plus 2i root of 3 divided by 2. And here you get minus 2 minus 2i root 3 divided by 2. So this guy will be minus 2 plus, okay, sorry. This 2, 2, 2, you can cancel. You'll be, you get something like minus 1 plus root 3i, okay? And for this second, you get minus 1 minus root 3i, okay? So these are the solution. Here we have found that P is this, and this. P is 2 and P is minus 1 plus root 3i, and P is minus 1 minus root 3i. These are the values of P. So what you are going to do, you are going to see, okay, to substitute this value of P if you feel like. Sorry. We are solving for P. If we are solving for P, it's impossible to you to put this value here and just find the solution, okay? No way, okay? Here, when we are solving for P, we have to go to find what is dx by dy, because we have to make P is equal to dx by dy, okay? So now what you're going to see, so dy by dx for the first P, okay, is equal to 2, okay? And here I will have also dy by dx is equal to minus 1 plus root 3i, then dy by dx is equal to minus 1 minus root 3i. Okay? Now solve this equation. This will be very easy. dy and 2 dx. And here also dy is equal to minus 1 plus root 3i dx. And here dy is equal to minus 1 minus root 3i dx. So y is equal to 2x plus c1. Y is equal to minus 1 plus root 3i. X plus C2. And here y is equal to minus 1 minus root 3 I time x plus C3. Okay? These are the solution of my equation. So what will be my general solution then? I will write here, now that I have finished. This is the last exercise. Okay, now that I have finished, this is the last exercise, so it will be y minus 2x plus c1 times y minus will be minus 1 positive, then sorry, this will be plus 1 minus root 3I. Oh man, okay, this will be y minus, okay, 1 negative, no space, minus 1 plus root 3I x, okay, x plus c2 time, the third one is y minus, okay, this will be plus actually, okay, plus 1 plus root 3I time x plus c3 equal to 0. This will be my general solution. Okay? Yeah, just in this way. Okay? And yourself. Thank you very much. I hope you may enjoy. So I see you in the next video where we are going to start now what we said, higher order differential equation. Okay? And see, higher order differential equation, it is when the the differentiation, the highest differentiation in this equation is greater than 1. Like this. Equation like this. Okay? Plus 3 or plus suppose 6y plus y equal to 0. This one we call a homogeneous higher degree differential equation. Okay? This is homogeneous because this is 0. Okay? But suppose it is here we have a function of x and it is like this, in this way, like 3 plus 6, 3, 2 plus 4 y dash plus y. Suppose it is in this way, and here we have a function of x, so we can call, sometimes a function of x, okay? It's a function of x, but a function of x can be also a constant function. So it can be it can be a constant function like k, or it can be also a non-constant function like x, Euler x, and so on and on. Okay? When this equation, because these are linear, all of them are nothing more than linear high order differential higher order differential equation. It is higher order because the order of the derivative here is more than 1. Here it's 2, here it's 3. Okay? So when it is equal to something here, if a function of x, okay? And the function of x, I told you guys, a function of x can be constant or can be non-constant, like depending on x. So if it is true, this kind of equation we call linear higher order linear differential equation and non-homogeneous. It's like a higher order non-homogeneous linear differential equation. But this exercise like this, in this way, it will be called like a higher order homogeneous differential equation. Okay? And the solution for higher order differential equation, it is analyzed into like the general solution. It is like CF plus PI. Okay? Where CF, it is the solution given by the auxiliary equation, and It depends on the kind of auxiliary equation we have, on the kind of root we have, and so on and on. We are going to learn. And pi, it is the particular integration, like particular integration of this function of fx. Okay? So this will be a very good word. So you will enjoy this, I hope. And yeah, we will enjoy this that much. Then we will see this. What are the methods, these guys? We'll see this Frobenius, Lagrange, Legendre equation, Cauchy-Euler's equation. These are some variation of this higher order differential equation. So, thank you very much. See you when I see you. Please do not forget to share and subscribe, and just pull your buzzer of notification, and let us grow together. Thank you. And see, guys, I just forgot something here. Okay, here I put plus c. Okay, actually this is minus. Okay, here also it is minus root of 3. Okay, plus this is minus, and this is minus. Why minus? Because here, when you come here, this is minus, minus, minus. But see, it doesn't change anything. Even if I put here plus or minus, this c is a constant. Anyway, it will make no change, okay? Nothing. Thank you.